Since the beginning of time, humans have looked up into the night sky and wondered, where did we come from? What lies beyond those stars? And how did this universe begin? Our curiosity pushed us from cave drawings to telescopes, from simple observation to giant machines to explore the unknown. And that journey led to the most advanced eye we have ever created to study the universe. The James Webb Space Telescope. Welcome to the Hype Club. Let's get started. Webb is often called a time machine. That's because light takes time to travel. When Webb looks at a galaxy 13 billion light years away, it sees light that began its journey 13 billion years ago. So Webb is literally looking into the past, seeing the universe as it was shortly after it began. As the universe expanded, this ancient light stretched and shifted into infrared, a form of invisible heat. And infrared is exactly the type of light Webb was designed to see. So what exactly is the James Webb Telescope? In simple terms, it's a giant space camera that sees heat instead of visible light. This allows Webb to look through cosmic dust, uncover newborn stars, study distant planets, and observe the very first galaxies ever formed. But Webb's power comes from extraordinary engineering. At the heart of the telescope is its primary mirror. It's made from beryllium, an incredibly strong and lightweight metal that stays perfectly stable at extreme cold, even at minus 230 degrees Celsius. The mirror is coated with an ultra-thin layer of gold which reflects almost all infrared lights. This golden surface captures the faintest photons, tiny packets of ancient light that have traveled across the universe for billions of years. At 6.5 meters wide, the mirror was far too large to fit inside any rocket. So, engineers built it from 18 hexagonal segments that folded during launch and unfolded perfectly in space. To detect infrared light, Webb must stay extremely cold. That's why it carries a sun shield the size of a tennis court. This shield blocks heat from sun, earth, and moon. The sun-facing side reaches about plus 120 degrees Celsius, while the telescope side drops to minus 230 degrees Celsius. That's temperature difference of nearly 300 degrees across just 5 ultra-thin layers. The sun shield works like a giant umbrella in space, keeping Webb cold, silent, and permanently in shadow. One instrument called MRI needs to be even colder. It operates at minus 267 degrees Celsius, just a few degrees above absolute zero. A special cryocooler removes that last traces of heat, allowing MRI to detect extremely faint signals from distant galaxies and alien worlds. Now let's talk about how Webb captures light, where engineering meets the pure magic. When light from distant star reaches Webb, the primary mirror gathers it and reflects it into the secondary mirror. From there, the light travels deeper into the telescope through additional mirrors that sharpen and stabilize the image. Finally, the light enters Webb's cameras and spectrographs, where it's recorded, analyzed, and prepared for transmission back to Earth. But Webb doesn't just take pictures. It is a chemical detective. Using spectroscopy, Webb splits starlight into a rainbow. Instead, that rainbow are hidden chemical fingerprints, signatures of elements like hydrogen, oxygen, methane, and carbon dioxide. By reading these fingerprints, Webb can discover what stars are made up of, what gases surround distant planets, and whether a world far from us might contain water. Webb doesn't orbit Earth like Hubble telescope. Instead, it lives 1.5 million kilometers away at a special location called L2, where the gravity of Sun and Earth balance perfectly. At L2, the Sun, Earth, and Moon always stays on the other side of Webb. This allows the sun shield to block heat continuously while the telescope faces deep cold space. So now you must be wondering how all this information will reach us. Webb sends everything it sees, images, spectra, and system data across 1.5 million kilometers to Earth, traveling at a speed of light. The signal reaches us in just 5 seconds. Every single day, Webb sends back nearly 28 gigabytes of discoveries. The universe is literally downloading into our computers. And with that, our journey with James Webb Space Telescope comes to an end. If you enjoyed the video, please let me know in the comments and also let me know what we should explore the next. Thank you. Bye.